Hi students, coming to the next topic. Here we are going to discussing about input-output interface. Input-output interface. Here, input-output means we are expecting input means input devices, output means output devices. So here some external devices are there. Those external devices are some devices are input devices, some devices are output devices. So with the help of interfacing technique, we are going to transferring information those I/O devices to processor. The interface, what is meant by interface here? Interface is it is a medium which is used to connect in between two modules. What type of interface is needed to connect connection in between I/O devices to processor means depends upon that requirement. For example, generally input-output interface provides a method for transferring information between internal storage such as memory CPU registers. That means CPU memory inside some data content is there. The data content is transferred through this interface, and again those data is stored inside the I/O devices. Peripherals, generally these peripherals are connected to a computer. It needs some special communication links. These communication links will resolve some difficulties. That means differences. What are the differences we are going to observe here? In different parameters we are going to see. That means inside processor different electronic circuits are there. Externally we are electromechanical circuits are there. How we are going to resolving these differences in between processor and keyboards like this. So here the next slide goes to, these are the different devices we are going to observing for different aspects. For example, if it is in device category, some devices and signals are there. In peripheral count, that means some devices are electromechanical devices. So the difference is here, some devices are electronic devices. That means electronic devices manufactured by using the CPU and memory devices, and some electromechanical devices are manufactured by some peripherals. Some differences is there. That means while we are transferring some information or data from either CPU to peripherals or a peripheral to CPU, some different problems, different differences arises. To resolving those problems, we are implementing different interfacing techniques. So in data transfer rate, coming to the data transfer section, here peripherals usually very slower compared to the CPU and memory blocks. Here some kind of synchronization are needed to maintain the or resolving the problems. So coming to the unit of information, peripherals always it sends in the form of byte of information, but in CPU memory just you are calling in word size. How much data and word in the form of word size, the memory will holds the data, or in the form of word size, the CPU will process the information. Like this. Coming to the fourth one, operating modes. Peripherals always it sends in the form of, that means communication, like either autonomous communication or asynchronous communication. In the form of data we are transferring either autonomous or asynchronous. That is called the peripherals. Coming to this CPU or memory, always which transfers the communication internally in the form of synchronous communication. These are the either peripheral or CPU or memory different differences we are going to identify. Those differences will be resolved by the different interfacing techniques. So what are the interfacing techniques we are using to resolving the problems of the transferring data from external devices to processor? So one interfacing devices technique is there, and that means this is a interfacing device technique. This module, this hardware implementation, which provides the how the data will reach from the I/O devices to CPU. In this case, this block diagram completely, which represents either data is transferred from CPU to that means CPU to I/O devices or I/O devices to CPU through this interfacing module. So in this interfacing module, just listen constructional details. Some registers are there, some timing and control blocks are there. So inside some internal bus is there for connection of all the registers and blocks. So where internal bus, simply it is called the system bus. System bus is nothing but a address bus plus data bus plus control buses. This combination of these three buses is called a system bus. With the help of system bus, we are going to interconnect all the blocks in the hardware. Coming to the constructional details, first one, it is the data bus buffer. Data bus buffer in this case acts as a temporary storage register. So coming to this one, this is a register, that means all are rectangular boxes, so that all are represented as a register. Register is a group of flip-flop which is used to store the binary information, always which represents in rectangular boxes in any hardware block. So this is the port A register, port B register. This is the control register, this is the status register. Let us see one by one. Here port A register and port B register both are used to transfer the data from CPU to IO devices to CPU. Either that means bidirectional way. So that here the bidirectional bus we are going to observe in between this internal bus and port A, port B registers. Here also from port A to IO device bidirectional bus, here port B to IO devices bidirectional bus we are expecting in between port B and port A to port B, port A, port B to IO device, in between these two IO data, input output data purpose. Sometimes we are transferring like this, sometimes we are receiving like this. So that always it indicates bidirectional way. Coming to this one, control registers. Control register is a holds some control data. It means what type of control values we are receiving from this internal bus. Sometimes this control signal to control the various operations. That means various operation means sometimes the read signal is generated, sometimes the write signal is generated. So if it is a read signal is generated, at that time this particular IO device, whatever the IO device are, which that particular device is selected, that means peripheral device 1 and 2 and 3 and 4, 5, 6 and 7 and so on. So many devices we are expecting in this case IO devices case. Suppose second device is connected to this IO data bus. So control signal is a read signal is generated at that time. This second peripheral device is a read the data, that means sends the data to IO bus. That time this IO data bus is reads the information from the second peripheral devices and the data is placed on the this data bus. This data bus will carry like this through this port A or port B, depends upon the particular condition. So which port we have selected, either port A register or port B register. With the help of this tabular form, will decide which register is selected for the data transfer. If the port A is selected, the selected data is transferred through this register and it is placed into the inside bus. This inside bus will transfer like this through this internal bus, and again it is placed into the data bus buffer. Data bus buffer is reads information from the internal bus, that means system bus. Again that those binary information is transferred to CPU through this bidirectional data bus. This is all are parallel buses. So this is a parallel bus, this is a parallel bus, this is a parallel bus, this is a parallel, because we are receiving the parallel bus like this. Or sometimes if you want to transfer the information from CPU to IO devices, same as it is, which register data is selected or which memory location data we are selected, either register or memory location, whatever the source of the information we are selected, the particular source of information, the binary information is read from those locations. Again it is placed into the bidirectional data bus. Bidirectional data bus will carry like this and it is placed into the data bus buffer. Data bus buffer is acts as a temporary storage device. It will maintain the temporary data storage, always which provides a delay. So those binary information is transferred same information without loss. Whatever the information is received from this bidirectional data bus, without loss, those information will be sent to the internal bus. This internal bus will carry like this. Whatever the register we are going to select, either port A or port B. Through the particular register, the data is transferred like this. After register, this IO data bus comes into the picture. It will read the data. Again, it is placed into the selected desired location of the peripheral device. That means selected peripheral devices will receive that information from the IO data. This is the way we are going to transfer the information from IO devices to CPU, CPU to IO devices. Here, coming to the timing and control circuit diagram. Timing and control device always generates the timing and control signals to control the entire operation of this block. So Here, this timing and control signal generates the control signals based on these various inputs. Here, CS is chip, called as a chip select to enable the timing and control block, and the register select and the register select. RS1 and RS0 is used to select one particular register at a time. That means if port A is selected, at that time, that particular time, port B is disabled state, control register and status register. All the three register will go in disabled state. Port A is enabled. After enabled, remaining three register goes in disabled state. So the type of status is always maintained by RS0 and RS1. So in this case, IO read, IO write signal is used to control the peripheral IO device. Inside IO, that means peripheral data. If a read signal is generated, the read signal is generated, and the particular IO device will read the information it is placed into the IO device. If the write signal is generated, the particular device is receive information from IO data to that particular device, IO device. That means writing information into that particular IO device. Read means read the data from the particular IO device and it is placed into the data bus. So coming to this block diagram, before going to this one more register is there, that means status register. What is meant by status register? Status register always carries the status signal. What type of status we are receiving here? Before transferring either read or write operation, the particular device it is ready to accept or ready to send. While it is ready to accept, the device is ready or not. So if it is the device is ready, that time it will accept. If the device is ready, that time it will send. So the type of status signal will be carried by using the status register. Those register will transfer to internal bus. Those values again it is transferred like this, like this, like this, and it will reach the CPU. So coming to this tabular form, this tabular form which provides the control operation, which register is selected for those particular inputs. That means here port A register, port B register, control register, status register is there. So coming to this input section, here three inputs are there, chip select and RS1 and RS0. So initially chip select is 0. So chip select is equal to 0. That indicates this timing and control block goes to disabled state. If it goes to 0, no control signal will generate from this control signal. So no operation will be performed by using hardware module of this interface. So that time this RS0, RS1, whatever the signal either 0 or 1 is transferred, so no operation will be performed. That means the data bus will goes to high plane state. So coming to the next one, like in 4 cases, that means CS is carries 4 ones. So that time whatever the inputs is generated or that status signals is carried, the particular register will be enabled. So let us see here RS0, RS1, if it is carries both zeros, that time port A register is enabled. Through this port A, we are transferring the data or sending the data. That means this port A is used to transfer the data from either IO devices to CPU or CPU to IO devices. If it is carries 0, 1, port B register is selected to transfer in between CPU to or IO device or internal bus to high IO devices. Coming to the status control register and status register. If it is carries 1, 0 control register, if it is carries 1, 1 status register. With the help of these inputs, different registers we are going to selecting. With the help of selected register, we are going to transfer data from selected IO devices to internal bus to CPU through this data bus buffer. This is the way we are going to exchanging the information from one place to another place. Thank you.